Is that one 17 or 15?
I think we left off at number 1. I think we left off.
The one that doesn't have batteries, is it 17?
Yeah, it's 17.
Yeah, let's put that one back and grab one of the other ones. That one's having issues. All right. Is it that? Did we do that one?
Because it doesn't have any facts.
We did it or we did not? We didn't? Okay. All right. Let's start with that one then. Okay. There are 2 in here as we go through that we're going to get rid of. Okay. Alright. Oh, I didn't have an answer to that one, but it should be that. Okay. I'm going to at least show you how to, that might be one of the ones we need to get rid of, actually. Oh, I know what I told them to do during 4th period. You have an open calculator, don't you? Okay, let's put it in. Okay, so everybody right now practice putting that in your calculator and let's figure out what the decimal point is. Alright, so I don't have my calculator up and going and it'll take a while to get up. So, and you're going to go to the button next to the book, right? You've got your book button here, right? And then there's this button that's next to it. That's the one you want to push. And then you find the integral symbol. And you need to fill it in exactly the way this looks. Cube natural log of x dx. It's the button next to the book.
What does that get?
I don't know.
What's that supposed to be?
That's the button next to the book. I don't remember what it looks like.
It has a absolute value and
We're doing hieroglyphics on it?
thing next to it.
Yes.
72.785.
72.785. Do we agree with Kaylee? Huh? What?
That's what I do. I just type it into the calculator and then I look at the choices and type all the
Yeah.
choices.
Now, if I put that one on, I'd probably make those nicer answer choices. Okay? All right, everybody agree with the 72.785? Yeah. All right, and again, if you didn't hear what Kaylee said, she said, now what I would do is I would take these and find these decimal points and then match up which one matches that. Okay? It's not A, apparently. I don't know what the answer is. You guys have the study guide up. Huh? I'll take whatever you got. Okay.
Miss Bella, you said week is that? Week 17 is missing, but that was a day.
It was today. It's this week's. I put it in for everybody so you'd see what you have to finish.
Oh, but why? That makes us freak out.
I know. That's why I did it. To make you freak out to get it done. All right. All right. Kaylee stopped doing homework, so. All right. But it worked for Joaquin, so. Okay, let's talk about this one here, okay? So this is one where I take and I split off one of my cosines, all right? So we're going to really split it into cosine squared 2x, sine squared 2x, cosine 2x dx. Okay, so I took the cubed and I split it up into cosine squared and cosine 2x. Okay? All I did was split it off because I saw the odd exponent on there. Okay? The next thing I'm going to do is I'm going to use a Pythagorean identity to substitute into that. So what would I replace cosine squared with? 1 minus sine squared 2x. We've got a cosine 2x dx. All right, what are we going to do with this here? Distribute it. So we've got sine squared 2x minus sine to the 4th 2x, and I'm not going to distribute in the cosine. Okay, I'm just going to leave the cosine outside of it. All right, I do need a u substitution. Okay, what are we going to use as your u, do you think?
Sine squared, or sine of 2x.
Sine of 2x. Okay. So du is going to be, what's the derivative of sine?
Cosine.
Cosine 2x, what's the derivative of the 2? 2, and then we've got a dx.
Just 1/2.
I need to move the 1/2 over. Yep.
It's yes and no.
All right. So we have got, for this piece here, I'm subbing in u squared. For this piece here, I'm subbing in u to the 4th. The cosine 2x dx is the same as 1/2 du. Much easier to deal with that. All right, when we integrate u squared, we get u to the 3rd over 3 minus u to the 5th over 5 plus c. At that point, we're going to go ahead and sub our u back in. So I'm seeing 1/2 sine cubed x, sorry, not x, 2x, right? Because it was a u cubed, right? I'm just replacing the u with sine 2x over 3. Sometimes there's some in the boxes. Over 5 plus c. All right, here's the thing, is that is not one of our answer choices, right? I think we have to pull out, it looks like we've got to make it into a common denominator of 15. Maybe. Okay. Maybe not. Maybe I'll be nice with the answers. I don't know. All right, so I'm going to use 15 as my common denominator, and this is just an algebra piece, right? It's not the calculus piece. What do I have to multiply this by to get to 15? 5. Good. So we've got 5 sine cubed 2x. What does this one get multiplied by? 3. So that's 3 sine to the 5th 2x. I'm going to factor this piece out. Okay, so I'm factoring out the 15, which would be 15 times 2 makes it 30. The other thing I could factor out to make it match, look what else has to come out. A sine 2x has to come out. So that means I'm left with 5 sine squared 2x minus 3 sine to the 4th 2x. I don't know. I didn't write it. It is really annoying, yes. I know. All right, so it looks like B. What's wrong, Gam? Because look at your answer choices. You could, but it doesn't match your answer choices. Okay? All right, we good with 14? Okay, 15. All right. What I need you guys to get out in front of you is either in the front inside cover of your notes notebook or on your Chromebook. You need to put the trig table in front of you. The trig chart. Okay? You need your trig chart out for this one. The front inside cover of your notes notebook or inside your textbook or on the line. It's there. Okay? Okay. So this one here, I'm looking at this piece here, and there's two things that could be done with it. Either it's a double angle or it's a power reducing. And this one is going to be, I'm sorry, it's going to be a power reducing. Okay?
We did this year?
Yep. September. Okay. All right. So we're going to convert this into a power reducing. What is the power reducing that's sine? Just read me sine squared u. Somebody read it to me out of the book.
Is 1 minus cosine 2u
Over 2. Okay. So that's what I'm going to convert this into. All right. And notice that the u here is 4x. Okay. So we're rewriting this. So I've got the integral of 1/2 minus cosine 2 times 4x is going to be what? 8x, and then over 2. All I did was I split the fraction up, okay, to make it easier to integrate. Okay? I'm going to choose to do it in two separate integrals. When I integrate 1/2, what do we get? 1/2 x. All right, this right here, I'm going to have a 1/2 that I can pull out of it. I'm going to do a u substitution on it for the 8x part. So du is going to be what? 8 dx, which I don't have the 8, so I have 1/8 du. So I've got cosine of u, and then I have 1/8 du. So in front of this, what do we end up with? 1/16. When I integrate cosine, what do I get? Sine. And then instead of u, I'm going to write down 8x plus c. Okay. From here, it's none of our answer choices. Okay? So notice how I have a sine and a cosine. When that happens, this is an indicator I probably need to convert back to a double angle. So we're having to do 2 trig formulas in this one. I know. Okay? So 1/2 x minus 1/16. I'm now going to convert this thing here into a double angle. But let's think about this for a second. It's an 8. Okay? All right, so this thing here for a double angle, remember it's 2 times whatever's there. So it's really, that's the u you're looking for. Because look at all the answer choices. Don't they all have 4 x's in them? Okay, so double angle, give me what it says for double angle for sine. 2 times something. Sine.
U cosine U.
Cosine u. Okay, so sine 4x, cosine 4x. Our answer choices should be starting to look better. Okay. 2 goes into 16 how many times?
Like 8.
8 times. Okay. And then I need to get this up to a denominator of 8. So I'm going to multiply by 4, right? So I see 4x minus sine 4x cosine 4x all over 8. Isn't it? It's the second one, isn't it, B? Nope, it's not squared. It's C.
I quit.
This is not the whole test.
Definitely getting this.
This one is part of it, huh?
Definitely getting this.
What if that one's not there?
Well, I'm still getting it wrong.
It might not be there. You never know.
It should definitely not be there.
Okay. It will be between 25 and 30 questions long. So, and I think there's 40 some questions here. I usually do a double test, but we'll see how it happens. So we'll see what happens.
I thought it was going to be shorter because of the quiz.
Huh?
I thought it was going to be shorter because of the quiz.
Shorter final? So yeah, it's not 45 questions long. Okay.
So it's 35 now?
Between 25 and 30.
Oh!
Okay. Yeah, that's the final.
Okay.
Okay. You can handle that.
I can handle that.
Okay. All right. On this one here, we're going to break off. We're going to break the secant up a little bit. Okay. So I'm going to break this off into a secant squared and a secant to the 4th. So secant squared, because I know how to deal with the secant to the squared, right? And a secant to the 4th of 4x dx. What are we allowed to replace that one with there? 1 plus tangent squared 4x secant to the 4th 4x dx. Okay. Let's take a look at... All right, I'm going to distribute that in. So that's going to give me secant to the 4th 4x plus tangent squared 4x secant to the 4th 4x dx. And I'm going to choose to go 2 different integrals with it. This one's not looking good. I'm not seeing what I did with it last year. secant squared, because I know I can convert that to a tangent. Because look at the answers all have tangents in them, right? I'm checking to see if this is actually there. We might get rid of this one too. Okay, let's not do this one. Take 16 out.
Yay,
Yay.
One less you have to study. Okay. Alright, 17. This is a trig sub. So what you need to do is you need to get out your little trig sub chart. Find that little half piece of paper real quick. Okay. Your little yellow piece of paper
I'm gonna get one of these
with the
on
triangles. Yes, you're going to have one on this test.
I don't have any.
What?
Open up your book then. It's in your book somewhere. I don't remember where, but it's in your book somewhere. Or in your notebook. It's in your notebook. Look up trig sub in your notebook. Your notes notebook. Okay. So we're doing good old trig sub. We know that because of it being either a radical or a fractional exponent. Okay, that's our indicator. In fact, I'm going to rewrite this really quickly. I'm going to rewrite it as, shh, you're listening, the square root of 36 minus x squared cubed. Okay. All right, so I need to look at my chart, and I need to decide which row it is. So which row of the chart is it?
Wait, so A is the number used to.
A is the number, U is the variable.
So it's
Is that the sine row? Yeah, okay, so it's the sine row is what we're looking at. The first thing we do is set up our triangle. So in our triangle, what's going to go on the hypotenuse for the sine row?
6.
The 6, right? Because it's the square root of it.
Oh, yeah.
Okay, because remember, this is a squared. We just put a. All right, what's going to go on the opposite leg? U, which is just x. Okay, and then the other leg is always whatever the radical is. All right. Yep, this is trig substitution. Okay, so then I know that I have x equals, according to the formula on the chart, it says x equals what?
Wait, but does it give you what x equals?
6 sine theta.
It gives you what x equals.
Oh, it does it. Oh, it even gives us what x equals. I didn't even need to think about that. How nice was that? All right, so dx ends up equaling what?
6 cosine theta.
6 cosine theta d theta. Shh. All right, and then we also have an equation for the radical. What's wrong?
I know dx equal again. I forgot.
Derivative of that. Okay. All right, the radical comes from the chart. What does it say the radical should be?
6 squared. 6 squared minus 6 cosine.
6 cosine theta. There we go. Okay, now I'm going to substitute all this stuff into here. Okay? So, the x, it says, is 6 sine theta. So, I'm going to write 6 sine theta. The dx is 6 cosine theta d theta. The radical is 6 cosine theta, but I'm cubing that. In fact, I'm going to go ahead and write that all the way out. I'm not going to write it cubed. I'm going to write it 3 times. Okay, because I'm going to see things a little bit better if I write it 3 times. So 6 cosine theta and 6 cosine theta. Here's why I did that.
You can cancel.
I can cancel. So I get rid of a pair of 6's, or 2 pairs of 6's. What else cancels?
Cosine.
There's a cosine that cancels.
Yes.
Okay.
Cancel the middle one.
What?
You got math.
Because I like doing it on the middle one. I don't know. Just to bother you. Alright, so we've got, now we have, I have a 1 over cosine left. I have a, and I purposely did it that way, sine over cosine left. And I have a 1/6 left.
Secant times tangent.
So I have this together left. I have a cosine in the denominator left. And I've got a 6 in the denominator left. What's another name for 1 over cosine?
Secant.
Secant theta. What's another name for sine over cosine? Secant theta, tangent theta integrates to
Secant.
secant theta plus c. Now I come over here to my triangle. And secant of that triangle is what?
Hypotenuse over opposite.
Hypotenuse, which is 6, over adjacent, which is the square root of 36 minus x squared. What happens with these guys here?
They're gone.
They're gone. Plus c, so it's looking like answer choice B.
Yes. Let's see. For the answer.
All right, we go to 17.
Where's the 3 halves?
The 3 halves. Okay, so up here, the 3 halves is really saying it got converted into the square root of and then to the third power. Remember that the bottom goes back over the top of it as a root. And then I've got 3 of those roots according to what the cubing part.
Okay.
You okay, Gam, or no?
Wait, 1/2 exponent is the square root.
Yes. So it's really the same thing as saying 36 minus x squared to the 1/2 power cubed, right? And then I took the 1/2 power and put it back under the radical. Okay, it's the same thing. All right, we good? All right. What's wrong?
Why can't you just use it?
You could have probably used a u sub. We didn't use a trig sub, or we sometimes for trig sub we can use it. I used a trig sub because it said x equaled that. Okay. If you got it to work with the u sub, you can do it. Okay. All right. 18's gone. Put a big red X through it.
Let's go.
Okay. All right. Let's look at 19.
Little hospital.
Yep, we're gonna have to use L'Hopital. Okay. It's already kind of up there. So it already tells us that we have to use. Well, it says use L'Hopital if necessary. It is necessary because I can't put the 0 in the denominator. So I'm gonna start by going ahead and this is the same thing as saying this to the 1/2 power, right? So I'm going to take the derivative of the top, the derivative of the bottom. So limit as x approaches 0. The 1/2's going to come out in front. I've got 100 minus x squared to the what power if I'm taking the derivative?
So
Negative 1/2. I have to do the chain rule. What do I get out of the chain rule?
2x.
Negative 2x. What happens when I take the derivative of 10?
0.
Good. What about the derivative of the denominator? What do I get? 4. Good. Now, we're not going to freak out that we've got double fractions because look at what happens. Okay. The 2's cross out, so they're kind of gone. This exponent here is not happy where it's at, so I'm going to move it downstairs. So it's going to be 4 over the square root of 100 minus x squared. In the top, I'm left with a negative x. Is it okay to sub 0 into that now?
Yeah.
That will not get us a denominator of 0, so that works. I get 0 over some number, right? Which is still 0. All right, we good with that one? No? Because we took the derivative. We subtracted 2 over 2 off. Okay.
Point the trash can.
What's the 0 over?
You going?
A number.
Why is it just a number?
Because it doesn't matter, because you're doing 0 divided by anything is 0. I didn't feel like figuring out the number. Alright, I believe it's 40 though, right? Okay, let's look at this one. You need your arc derivatives in front of you. Okay, so if you've got your derivatives out, we need to look for the arc sine derivative. Okay? Alright, so we've got the limit as x approaches 0. I'm going to do L'Hopital again. Alright, so what is the derivative of arc sine? Okay, we'll look it up. You all have book. There's a book I see right next to you, Cody, looking for derivative of arc sine.
Are we going to have a chart that tells us that?
No, you're supposed to have that one memorized.
The arcs. Where is it even at?
Look on the inside front cover of your textbook.
Oh, the textbook.
Mm-hmm. All the derivatives and integrals are there.
What arc at, good? Alright, which one we need? Arc sign?
Arc sign.
I got you, fam. U over, no, it's U prime over rad 1 minus U squared.
Okay, so 1 over 1 minus u squared?
Yeah.
Okay, so our u is this thing in here, right? So when I square that, what do we get?
Like 49.
Good. And then we have to do the chain rule on the inside, so what does the chain rule give us?
Wait, why are you putting the squared
Times
again?
7.
7. Because it was u squared, right?
But then why'd you put a squared again?
Because I had to square the x.
Well, Cody, you're getting me confused, boy.
7x squared is 49x squared. Okay? And then the chain rule piece, the derivative of 7x is 7. So that's going to go on the top.
See right there.
All right. On the bottom, what's the derivative of the bottom for L'Hopital?
9.
9. What am I going to plug into this thing?
0?
0. So what's going to happen with this right here?
It's gone.
It's gone. So I really have 7 over 1 over 9, which is really
E.
7/9.
Wait, so if I see a problem like that on the test, I
Mm-hmm.
can just cancel out the arc sign and 2 x's and I'll get the answer. Right?
Well, maybe. Might not work. It might work, it might not. I don't know. I haven't done enough research on it. Alright. L'Hopital possibly again here.
Little hospital.
Okay, so we've got the limit as x approaches infinity. What's the derivative of the natural log of x squared?
1 over x squared.
Times 2x.
1 over x squared.
2 over x.
And then we've got to take the chain rule derivative gives me
Hotel.
2x.
Hotel.
Alright. What's the derivative of x to the 5th?
It's like 5x to the 4th or something.
5x to the 4th. Here's the problem. Okay. I could simplify a little bit, right? So couldn't I get rid of... Oops, sorry, not eraser. I want a different pen color. Okay. I could get rid of that x and make this just an x, right? Which is really saying we have... Oh, I got it a lot easier than I did on Saturday. Let's rearrange it a little bit. Okay, so see what I can do with it if I can cancel some more. We've got 2 over x, and then here, can't I flip that to 1 over... Yeah, I can do the reciprocal. So that gives me 2 over
5x to the 5th.
5x to the 5th. Can I go ahead and... I haven't taken the limit yet.
Wait, but do you have to flip it over?
It's 0.
Because if you plug infinity and then the top equals 0.
Then the top equals 0. It's going to get there, yeah.
Yeah, that's what I was
There's more than one way to do it. Alright, so if I... Oh, it's not 0, sorry. It's not infinity. Sorry, it's 0. Right? Because if I put the infinity in, I've got 2 over a giant number, which is going to be 0. I think on Saturday we kept doing L'Hopital's rule for a while.
Little hospital.
Little hotel.
Little emergency room.
Little emergency. Little ICU.
Alright, we good with 21?
Can't.
John Cena.
You're an ICU.
Alright, 22.
22.
It says determine whether the improper interval converges or diverges, so I have to convert it into our improper integral. So we've got the limit as b approaches infinity of 4 to b of 12, and I'm going to go ahead and bring that exponent upstairs by making it negative. So I am going to, I've still got the limit as b approaches infinity. I'm going to go ahead and integrate, so that gives me 12x to the what when I add 1?
Negative 5.
-5 over -5 from 4 to b. I probably would make it, I'd move my exponent downstairs, so I really have -12 fifths over x to the 5th from 4 to b.
Wait, what?
I just brought it downstairs. That's all I did with the exponent. I kind of floated the negative up. Alright, yes. So the limit as b approaches infinity of negative 12 over 5b to the 5th minus negative 12 over 5 4 to the 5th. Alright, let's think about what happens now. When I put infinity into here, I get a negative 12 over a giant number. What is that going to equal? 0. So isn't it just whatever this back term turns out to be? I wrote down that it was the A answer.
What? You just guessed.
I wrote down from what I wrote out last year that it was the A answer. Couldn't you put that in your calculator? Aren't we all capable of doing that?
I don't believe you. Someone put it in.
Okay, put it in.
Calculator's not a class.
It isn't.
12 over 9. I got 3 over 1,281.
81?
I'm just playing. You got it.
I didn't think so. Because it's going to be an even number times 5. Alright. So, we're going to determine if the improper integral converges or diverges.
Can you go back for like 2 seconds?
I can go back for 2 seconds, yep.
Finesse the whole class.
1, 2.
I really just need to know what answer choice it was.
Oh, okay.
Like, I really only needed 2 seconds.
Okay. Alright. So we got to determine if the improper integral converges or diverges. I would probably think of it more in this context here. 1 over 1 minus x to the 1/8 power, right? Okay, and isn't that a
P-series.
kind of like a p-series? Yep. It's similar to a p-series. It's a 1/8, right?
Have you ever taken the 1/8 or something?
Yeah, we got to do...
Or have you ever like taken that the 8th root or something?
Have I?
Yeah.
Probably not recently. Okay.
You probably have mad.
Alright, so
I'm gonna take the 8th.
I've got that p is equal to 1/8. I have to figure out if it converges or diverges. There was another property embedded in our notes somewhere. It was in the chapter 8 stuff. That if p was less than 1, that we could put it into this formula. Okay? So, yeah, it was a long, long time ago. Or not that, weirdly wasn't that long ago. So I'm gonna, because I have to calculate it. We know it doesn't diverge, right? Because p is not greater than 1 if it diverges, if it's p is greater than 1. So it's 1 over 1 minus, what's the p value? 1/8. And so let's see, if I start playing with the arithmetic on that, I get 1 over 7/8,
Or 8/7.
which is really 8/7.
That's what it's super great.
Yep,
Is that the answer?
that's the answer.
Oh. Sick.
Wait. So, does it convert
It says evaluate the integral if it converges, so it evaluates to 8/7. So it converges, yes. You're in Hemet.
It converges if p is less than 1?
If p is less than 1, yes. Alright, we good with 23?
I like what is divergence.
Alright, you're gonna like 24.
Ooh! Oh.
So do we get points if we just draw an X on the test?
It won't be on the test.
Okay, how do you do
For
that?
number 24 on the test, if I draw an X, I get
I think it's an nth term, but I don't know with that. It only really is supposed to be geometric. That's why I took it off. Okay? Yeah, that's why I took it off. Because I was confused too, so I decided it was better not to put it on there. Okay. This one here, it's probably not going to be answer choice A. That cannot be determined by methods in this chapter. It's going to be either converges or diverges. Okay? We're going to use the nth term test on it. Because it doesn't really fit a geometric, it doesn't really fit a p-series. It's not alternating, so if I can try an nth term before I try to go to integral test or limit comparison or direct comparison, that's probably a good plan. So I'm going to act the nth term. Remember, we take the limit as n, or in this case, or really we convert it to x's, right? Goes to infinity.
Yeah.
5 to the x over x to the 5th. All we did was put x's. You could leave it in n's and just do n approaches infinity if you wanted to. All right, can't do it the way it is. We get infinity over infinity, so what do we have to use? We have to use L'Hopital. Okay, so what's the derivative? Be careful with the derivative of the top. This is one you probably should know for the final.
It's like 1/5.
No, it's x, right?
Wait.
X to the 5th.
It's x. It's 5 to the x. But there's something that goes out in front of it.
Times the natural log of 5.
So it's your base. It's the exact same thing, just like e to the x is e to the x, right? But then with the base that's not an e, you had to multiply by the natural log of 5. Okay?
Wait, so the derivative of 5 to the x is
Natural log of 5 times 5 to the x. Okay? All right, what's the derivative of the denominator?
5x to the 4th.
5x to the 4th. This is the one I was thinking about from Saturday. All right, here's the problem. I still have to do L'Hopital again, right? Because I still have an infinity over infinity. So the limit as x approaches infinity. The natural log of 5 is just the natural. It's just a number, right? So it's a coefficient. It gets the state. What's the derivative of this?
The same.
Natural log of 5, right?
It's 5 to the x with the natural log of 5. So can't I just square it? And then what's the derivative of the denominator?
20x cubed.
Oh, let's keep doing it.
Yes, we have to keep doing it until we get to no variable in the denominator.
We have to do it 3 more times.
Okay, so we got to do it a few more times. So the limit as x approaches infinity, yes.
If it's pi, it diverges, right? I mean, not pi.
If it's infinity, it
Can't
diverges.
you tell it's gonna be infinity? Let's keep going until.
It's gonna be 0 though.
No, because it's infinity over infinity, so it's like the indefinite or whatever.
Yeah, we got to keep going till we don't get infinity over infinity. Okay? Though I think you might be, your thinking is on the right track, Joaquin. Okay? If you were pressed for time, you'd probably guess well. Okay? All right, so I got, what power is this going to go to now?
Squared.
It was squared, it's going to go to cubed on the natural log, and then what's the derivative? 20x cubed.
Oh, I thought we were talking about the denominator.
All right, the limit as x approaches infinity, 5 to the x is going to be natural log to the 4th, and then the derivative of the denominator is
Yay, one more.
120x.
120x, good. The limit as x approaches infinity. Okay, so we get the natural log of 5x to, or natural log to the 5th times 5x, and then the denominator is 120. Now, was Joaquin right in his thinking a few minutes ago? Yeah, because the denominator is going to be a number, but the top is still going to be infinity, isn't it? Yeah, so it's going to end up being infinity, so does it converge or diverge?
It diverges.
Hey, I
It
got
diverges.
Should take that for a walk.
Yeah?
Should. No, I thought you were.
That one looks really fancy that you know, like you know a lot of stuff once you see the pattern.
Yeah.
It really isn't that bad. All right.
Well, yeah, all you have to do is realize that the top is still gonna have x's in it.
Yes.
Is this the exact same thing?
Is this one? No. This one is geometric, right? So let's see if we can let's see if we can convert it into a geometric. So n equals 0 to infinity. Shh. Couldn't I write it as x over 6 to the n?
Yeah.
Okay. So I do know that I have, because I have to figure out which one of these it is.
geometric.
Huh?
Yeah, it's gonna be.
It's geometric. I think that this one might get tossed too here in a second, but let's
yeah, let's just toss it right now.
let's play with it for a second. So I know that I have this formula, right? Okay, that's our geometric formula. It's on your chart, your yellow and green, your red, yellow, and green chart.
What's the A?
The A is the first term, so it's whatever's in front here.
So 1.
Because in this case, when I put 0 in, wouldn't I get a 1 out of it? Yeah, so it would be 1 over 1 minus the ratio would be x over 6. All right, so if I were to start playing with that, wouldn't I get 6 over 6?
6 minus x over 6.
So it'd be 1 over 6 minus x over 6, and then if I flipped that around, it would be this, right? Which gets me, get rid of this one, and rid of that one. What I don't think I've taught you yet, though, is this piece. So I kind of think this one snuck in there and wasn't a good question. So we can probably cross that one out.
Wait, so how did that turn into that?
How did this thing here turn into this?
Yes.
I recognized that this exponent was the same, and so I pulled out the exponent and I kind of factored it out.
Wait, so
That isn't really what it's called, but because I also can distribute that exponent back in, couldn't I?
Wait, so
And
how
I'd
do
be
you know
back
what
to
it's
this.
between?
I feel like the answer is definitely D.
You think that it's B? It's not B.
D.
D, because it's between -1/6 and 1/6. I haven't taught you yet to decide where it converges to, so I think it's a bad question. So we're gonna get rid of it.
Answer.
I don't know off the top of my head. Look in your, it's on there, printed somewhere.
Yeah.
I didn't write it down in answer. All right. So see, I've eliminated a few of them for you. All right, integral test.
Oh,
It
it's
tells you that you get to use the integral test. Okay. And you want to try to use the integral test because it says the integral test is inconclusive as one of the choices. So there were a couple of things I had to make sure happened. Didn't I have to make sure the terms were decreasing before I used the integral test? Yeah. So let's plug in a few terms just to make sure of that. So I'm going to plug in a 1. What do I get if it's what do I get if I plug a 1? 1/10, and then I plug in a 2. What do I get?
1/19.
And I plug in a 3, and I get.
1/28.
Are the terms decreasing?
Definitely.
Definitely. All right, so I'm going to go ahead and use my integral test. So I've got the limit as b approaches infinity. The integral from 1 to b of 1/9x plus 1 dx. I'm going to have to use a u substitution.
For 9x.
So I'm going to use 9x plus 1 as my u. So du is equal to what?
9.
Wait, the integral test is just where you take the integral?
It's basically an improper integral. We just put the name of integral test on it later. Okay? Alright, I gotta move the 9 over, so 1/9 du equals dx. So if I subbed in limit as b approaches infinity of 1/9 from 1 to b, 1/u du. Right? I put the u in for the 9x, I put the 1/9 du in for dx. Alright. What if so I'm going to put I've got the limit as b approaches infinity, 1/9. What do I get when I integrate 1 over u? Natural log absolute value of u from 1 to b. So I'm going to put my u back in, which is the 9x plus 1. We're going to plop our b and our 1 in. So the limit as b approaches infinity of 1/9 natural log absolute value of 9b plus 1 plus 1/9 natural log absolute value. 9 plus 1 is going to be 10, right?
There's an infinity, so
And I'm going to put an infinity into that. What's that going to be?
diverges.
Infinity minus or plus whatever this thing is, right? So does it converge or diverge?
Diverge.
It diverges because it's infinity. You guys remember, you're taking a multiple choice test. Once you get to this part, okay, you know you're going to plop. Could you even not even put the b in and put the infinity in right there? Yeah, I'm not going to see your work. Well, I could see your work, but I'm not going to look at it.
So what would be converges? Just a number?
It converges would be any number.
Okay.
Diverges is infinity, converges is any number. Okay? Alright, it doesn't converge to that number, but it tells us that it converges. Okay? Alright, let's look at 28. What kind of test is 28?
P.
P series. And again, I'm not writing down nearly as much work as when I taught them to you. What's your P equal to? 8 fifths.
It's greater than 1, so it diverges.
It's greater than 1. Do we all agree that it diverges? Yeah, and I'm not worried about the 9.111. It's probably going to still say that on the test, but that's just your P series theorem.
That kind of scared me.
I don't know. Let's look.
No.
20 is, let's see,
Because if
P
it
series,
converges, you obviously-
greater than 1, yes, it converges.
Never mind.
We're wrong.
Converge.
You gotta use our chart, because I don't have the chart memorized either. So it
Hey, are you gonna give us
converges.
the flowchart for the test?
Yes, the flow chart will be there for the test. Remember, you're getting 3 things. You're getting the flow chart, you're going to get the little trig substitution one, and you'll get the trig chart. You won't get your derivatives and integrals.
And the answers too.
No.
Wait, what's the difference between the
The answers will be A, B,
trig
C, D, or E.
substitution and the trig chart?
Huh?
What's the trig substitution? and
The
trig
trig substitution is the little triangle setup.
What's the trig
Okay.
chart?
The trig chart is your trig, right?
Oh,
Yeah.
like the double angles?
Yeah, the double angles and the half angles and all those. Okay? Alright. 29, we're going to determine the convergence or divergence. This one is also a P series. You just have to get it into the P.
P theory.
So n equals 1 to infinity. We're going to do 3 over... I'm going to rewrite this. This is really n to the 1/6 power right back here. So I'm going to make this one 6 over 6. So when we're multiplying, don't we add our exponents?
Yeah, n to the 7/6.
That was kind of
N to the 7/6. So what does that mean P equals?
So it converges.
7/6.
So it converges.
What is that?
Converge.
Oh, it's 6.
7/6. It's 6/6 up there.
You say 6.
Alright, we go to 29?
No.
No?
I don't know how to do one still.
Well, I'm not done yet. I still have all the ones that are the AB ones too.
To be fair, I don't know how to do
Alright, what kind of series is number 30?
it.
It's a P series as well, right? What's your P equal to?
1.1.
1.1, so it's greater than 1, so does it converge or diverges? Converges again.
That one was tough.
Yep. Alright, 31 says we got to use the direct comparison test. Probably would compare it to what?
7n.
I'd probably compare it to 1 over n cubed, right?
Oh yeah, you're smart.
Alright, because that's a P series, right? Does that P, the P is equal to 3, which is greater than 1, so does it converge or diverge?
Absolutely or something.
No, just converges. Remember, this is the BCSD. Okay?
Okay.
So I want this one to be bigger. I'm hoping this is bigger. So I have to actually, the only other thing I have to do is compare it.
It's bigger.
So
Wait,
7.
Which one has to be bigger?
The new one.
The comparison has to be bigger. So this is talking about what's happening with the comparison test. Okay?
So you just take the first exponent?
All I did was I kind of took this piece, right? I took the coefficient off of it. I know I can figure out, I know that that's a P series, so I know I can tell if it converges or
If you had,
diverges.
like, what if it was like 7n cubed minus 2n squared?
Minus 2n squared, I'd probably still will do 1 over n cubed.
Okay.
Okay? Alright, so if I started putting some numbers in, notice, what number does it say we're starting with?
3.
3. So let's put a 3 into it and see what happens. 3 cubed is 27, isn't it?
Yes, it is.
Alright, so 27 times 7 is what?
Shoot.
You all have calculators.
Well, isn't it going to be bigger because it's...
I hope so.
It's obviously bigger.
It's obviously bigger, because this is going to be a bigger number, which makes this smaller, right?
No.
Well, it makes this smaller. Yeah.
Makes that small.
I drew my inequality sign the wrong way.
Alright.
Alright, so the BCSD says if the bigger one converges, which was our comparison, that the other one also converges, so this one converges.
How many questions is on this study guide thing?
34 plus then there's the additional, I think there's 40 some total.
Wait, what's the absolutely in...
That's the alternating
Oh.
series. Okay. Alright, let's look at 32. We got to do a limit comparison test on it. So again, you're going to use your chart hopefully to help you out. This is where we have to sub in the we have to do a comparison. What's our comparison going to be? I'd probably just drop the 2, right? For the comparison. So the limit as n approaches infinity of our original dn minus 2. Oh, okay. I'll have yours tomorrow, okay? Alejandra.
You still don't have mine. See it?
Yeah.
What happened with mine?
Because I missed ordering something on it. So
Uh-huh.
I'll have it tomorrow. I didn't go and get it this weekend, but I'm going to go right after school.
Okay, that's fine. Thank you.
All right. Let's do, we're going, I said I would compare to, I just dropped the 2, right?
Yeah.
Over 9 to the n.
Drop the deuce.
Okay. And then we know that we've got, and we basically just use a direct, it ends up being a direct comparison. So, or not direct, but an nth term test. All right, so I'm going to go ahead and flip it and multiply, right? N approaches infinity of 3 to the n plus 1 over 9 n plus 2 times 9 to the n over 3n plus 1. What happens with these guys?
They're canceled out.
Cancel. We have 2 minutes, sorry. 1 minute.
You compared it to.
I compared it to, I just dropped this on my comparison. Okay, I don't know what
Why did you keep the old one on top though?
because that's the limit comparison test. You're supposed to keep the old one on top over what you're comparing to. Okay? Alright, I'm going to stop because the bell's going to ring. Yes. I've communicated with them. They said we were supposed to get it. I will email them again. I know I know we owe you. I know, no, it's still on my radar. Alright. Okay. So we've got to talk about absolutely and conditionally on this one. So what's the first thing I do? We do the absolute value of it. So we really are looking at the sum as n equals 1 to infinity of 1 over n to the 3/7. So it's a p series. What is your p equal to? 3/7, which is less than or equal to 1. So what is that, converge or diverge? Diverge it. So that means I cannot converge absolutely. Okay, it's either conditional or it diverges overall. Okay, so the next thing I do is I go to my alternating series test. Maybe. It's not letting me write. I really need new batteries, apparently. Okay, so we're going to do alternating series. So the alternating series says we have to do the limit as n approaches infinity of 1 over n to the 3/7. So I get a big number over a small a small number over a big number, which equals what? 0. So that's the first thing I'm supposed to check. The second thing I have to check is for decreasing terms, right? So let's start putting some numbers in. It says I'm supposed to start with 1. So 1 to the 3/7 is still just 1, isn't it? Then it would be 2 to the 3/7, and then it would be 3 to the 3/7. So do me a favor. Let's put these in and get some decimal points going out of this. And make sure it's decreasing. So help me out with the calculator, because I don't have this one written down anywhere.
The first one, 1 over 2,
Uh-huh.
that is 0.742.
0.742? Okay. I gotta redo the pen again. Maybe, if it'll let me. Keep doing the other one. I've got it, 0.742. There it goes. Okay, 0.742. What's the other one? Do we agree that it's decreasing then? So we know that it converges by alternating, so it converges conditionally.
Is that?
Yes.
So I just want to clarify that since it diverged, it doesn't that converge absolutely, right?
It can't converge absolutely. Correct. Okay. I think that one's not so bad, right? It really isn't that bad. Okay. This one here says we got to use the alternating series test. So all that is the nth term, the what we did on the last two steps, right? I don't have to do the absolute or conditional, so I'm just going to do the last two steps. So the first thing I'm going to do is limit as n approaches infinity, not 0. Of 7n squared plus 6 over 6n to the 4th plus 9n plus 7. We could do L'Hopital a bunch of times, okay? Or couldn't we just look at our exponents? Well, actually, if we did L'Hopital, we'd have 14n over, what, 24n cubed? If I did L'Hopital, I'd get 14 over something n squared. So I have a small number over infinity, which is going to equal what? 0. So step 1 is fulfilled. Step 2 says I got to make sure the terms are decreasing. So I'm thinking about plugging into here. It looks like I plug a 1 in first. So let's see, I've seen 13 over 13 plus 9. So 20 what? 20, is it 24? Is that right? Or is it 23? 22? 22. I'm wrong. Alright, 22. So 13 over 22. Let's get the next one in there. So then the next one, I'm not going to let you guys do it. Put in an n equals 2, and then put in an n equals... If you want to do decimal points, that's fine. So why don't we have Sierra's side of the room do the 2 and Marlette's side of the room do the 3. Okay, and what do we get for the 2? Decimal's fine. 2801. Okay, what about the 3? 132. I put in the 13 over 2. I got 0.59. So are they decreasing? Yep. So does it converge or diverge? Converges. Okay. All right. So that takes us to the end of the official BC stuff, right? Then there was also some AB stuff. Do we want to try to get through as much of that as we can? Or if we had it? We've had it. We want to do this stuff tomorrow. So remember there was an additional worksheet I put out there on Friday. Okay. I gave you another 14 problems that are a little bit more AB focused. So I can take the some of the harder problems, super hard problems out, right? And put in some more problems that are a little bit easier. The final will be, but definitely be between 25 and 30 questions. Okay?
Yeah, how many points?
I typically do about a double test, but I like to kind of wait and see how we do overall.
Okay.
Okay? So I'll start with it probably being in the between 1,500 and 2,000 range, and then I'll bring it down to what we needed to bring it down to. Okay? All right? Okay, so I'm going to stop there. Tomorrow's the last day we can stamp anything. I don't come in here on Wednesday and ask me to stamp something. I won't do it. Okay? No matter what the sob story is. All right, so if you need something stamped, you can stamp now. You've also got time to work through a little bit more. Okay? What? Yeah, tomorrow we can do these last few problems. Okay? And I will try to get both the videos up this afternoon. Paris, here you go.